Okay, so terrain. Um, so I'll start with the resource loader. Where is that? Here. Okay, so inside the resource loader, the user specifies the name of the height map that they want to use to call it, the actual height map file, the texture used for the height map, the length of cell, the max height, its position in world, and its UV repeats. So this gets loaded into the terrain asset manager. Um, so I can actually go to this. Okay. So this is responsible for storing all of my terrains, all of my loaded in terrains, and it's also responsible for unloading them when I close down. Um, so I'm storing, like all my other assets, I'm storing them in a map. Where's the... Here. Okay, yeah, here. Um, so it's just ease of access for the user. And the way I have the way I imagine terrain being used is the user's only gonna grab a terrain at the beginning of the scene when they set the current terrain. They're not gonna be swapping them out every other frame. It's just gonna happen once on initialization. Um, so yeah, here's a user-defined scene. So I imagine they're just going to call set terrain at the beginning of the scene to set the terrain, and that's it. That's the only place where they're going to call it. So I'm not too worried about access time of the actual terrain from the map. Um, yeah. Okay. Okay, so that's my terrain asset manager. Um, I also have a scene level terrain manager. Um, so that's where this is getting stored. So yeah, the scene level terrain manager that just stores the current terrain, and then it's just used to if anything needs to access it, it goes through the scene manager to access to the terrain manager to access the actual uh, terrain. Yeah. So now the actual terrain. So on creation, I take my file path. I grab the height map, put it into a scratch. No, into an image, yeah. And then I can use that to, and then I can read that in order to get y values for my heights. So yeah. So after that, I then create my array of vertices. So that's right here. So grabbing my H, then all of this is getting the normals of my surrounding faces for my point that I'm creating, for my vertex that I'm creating, and then averaging those faces out to get the normal of my vertex, which I'm storing inside the vertex, but I'm also storing inside the terrain in an array. Um, because I use that later for the terrain follow computations. So I just have a copy of that inside the terrain. Um, so after I build my vertices, I then wind my triangles. When I wind my triangles, that's when I construct my array of cells. Um, So the cells, I try to keep them lightweight. The only thing they store is their I and J indice and their min and their max height values. Um, so yeah, I'll, I access the cell data when testing collisions with the terrain. Um, yeah. Okay. So as for the okay, so winding triangles, and then I use my vertices and my triangles to construct my where is it? My model, yeah. And then I delete them because the model stores a copy of the my list of verts and triangles anyway, so no real need to store them twice. Um, yeah. So as for method, a couple internal methods just for accessing either a given cell, given an index, or given pixel or vertice, all of which given an index. So yeah, the user doesn't touch those ever. That's just done inside of the terrain class. As for the methods that the user actually uses, for the most part, all these do is they just take a position in the world and then map that to a position or orientation on the terrain. So world position to terrain, pass in a position, and it returns a point on top of the precisely on top of the terrain based off of the position passed in. So just going over this really quick. So I take my position, subtract my offset, divide by length. That puts my position inside of space in relation to the terrain. So grid space. And then this is just a check to make sure that it essentially just clamps the point inside of the z and x boundaries of the terrain. So if the point is outside of the, if it's either less than, if it's outside of the range of the terrain, then it'll clamp it back onto the terrain. So this prevents any errors with falling, like going off of the terrain. Well, because, well, in actuality, this prevents an object from leaving the terrain. So yeah. So then from my grip position, if I just take the integer values of that, that'll give me my I and J indices on top of the grid. If I take those and subtract it from my grid space, my indices, and subtract it from my grid space, I can then get my barycentric coordinates from my given position. So that's what X and Z are. And then I can plug those in. I can use those along with my surrounding vertices for the given triangle that I'm in to determine my exact position on top of the terrain. So yeah. So get norm from position, it's essentially the same thing. Given a position, put that into grid space, then put that into cell space to get your barycentric coordinates, and then take your barycentric coordinates and use them with your the norms of your surrounding vertices to get your norm at that specific position, and then you can use that norm to reorient your rotation. So yeah, and then orient rotation and position to terrain. So this is essentially the train follow method. So pass in a rotation, pass in the position. It'll call get norm from position to get your norm. It'll then reorientate the rotation, and then it'll call world position to train, which will then put the in position on directly on top of the train. And so yeah, so then you'd have so if this was an object, it would clamp its position to the train and then orient its rotation to follow the train. So yeah, that's train follow right there. Let's see. I think next is collisions. Yes. Yeah. Yeah. Okay. So collision. I'll go back to the scene. So in initialization, an object has to specify if it collides with the train. So this will then create a collision command between each of these classes and the terrain. So let me just go to that. So yeah, this is a collision test terrain command. So it stores the a collidable group and the terrain that it's going to be compared against. So for each of the collidables, I grab its B-sphere. Wait, where is that? Yeah. Okay, so I grab its B-sphere. I then construct well, I get the min position and max position of that B-sphere to essentially create an AABB, but I'm not actually creating an AABB here. So that's happening here. Oh yeah. So then, given my B-sphere, I create a collision rectangle on top of the grid. So it's just a rectangle that would be directly below the B-sphere on which actually follows the terrain. So the terrain rectangle, actually, no. So the terrain rectangle, all it is a it just stores the minimum cell that the B-sphere is potentially colliding with, and the maximum cell that the B-sphere is potentially colliding with. Given that data, it can iterate through so yeah, it can iterate it given those 2 points, it knows, like, it can figure out like what cells that it needs to test during collision. So yeah. So then I create an iterator. The iterator then, well, iterates through the rectangle to test collisions. So where's my iterator? So yeah, it's a subclass of the terrain rectangle. So it stores its current cell along with its min and max I and j. So it needs these points to know, like, when it's actually iterating through the collision rectangle when it needs to increment its j rather and reset its I, or just move its I. So yeah. Okay. So then for each cell being tested, okay, yeah, I just do a preliminary test against the AABB around the collidable B sphere against the my specific cell's min and max. So if the AABB and my cells AABB are colliding, then it'll do more. It'll do a test on the actual collision volume to check if it's true. To check if there's an intersection. And yeah, if there's an intersection, it'll register as true, and then afterwards it'll call collision on the collidable object being tested. So yeah, that's terrain. I think it in the checklist it also wanted to check the sides. So as I mentioned, it doesn't crash or anything, but oh jeez, that's ugly. So it can't leave the terrain. So it sometimes glitches out when it goes against the outside. Part of this is because like I really shrunk down this terrain just for ease of testing, so it's a bit more glitchy than how it would look on the actual game terrains. But yeah, it doesn't crash or anything. So yeah. And then if I just to test here. So just to test termination. So it hits the termination. And then deletes all the no, stop. And then it deletes all the terrains. Okay, so that was terrain.